Okay, so today we're going to look at these two functions and the graph that they make, and we're going to try to find the velocity and the acceleration of these two functions and the graph that they make. So the first thing we want to do is x and y. Let's take the first derivative. So dx with respect to t. So our first derivative is going to be negative r w sine wt. And then our first derivative in y is going to end up being r cosine, rw cosine wt. Let's take the second derivative. Second derivative with respect to t is going to be negative r w squared cosine wt. Second derivative with respect to t in the y direction is going to end up being negative negative rw squared sine wt. All right, so we have our derivatives. Let's see how they all play into our function of velocity. So our function of velocity is going to look like this. ds dt squared is going to be to dx dt squared plus dy dt squared. This is going to tell us what's happening in our velocity side. So let's throw it in there. ds dt squared is going to be equal to our dx dt squared. So this is going to be negative r w sine wt. We're going to square this thing plus this thing squared, which is r w cosine wt, and we're going to square that thing. All right, so let's square and see where we go from there. So ds dt squared is going to end up being, it's a bunch of stuff here, but we'll do it anyway. So this is going to be r squared w squared sine squared times wt plus r squared w squared cosine squared wt. All right, let's keep on going. Let's factor out the rw squareds. So ds dt squared is going to be equal to r squared w2 squared sine squared wt plus cosine squared wt. And we know that this is a trig function. This is equal to 1. So we know that ds dt squared is going to be equal to r squared w squared. Take the square root of both sides. We have ds dt is equal to rw. This is our velocity. This is our velocity in this particular case. Let's look at the acceleration. Using our acceleration formula, which is slightly different. So this would be d s dt squared. So this would be taking the derivative of this thing, which is going to be equal to our dx dt squared plus dy dt second derivative, and we're going to square this. So this is our function for acceleration. Well, we've already taken the derivatives, so let's just plug and chug and see what we get. So ds dt second function squared is going to be equal to, it's going to be a lot to write out, but we'll just do it anyway. We're going to square this thing. So this will be r squared w to the 4. Don't forget, this is a square up here. Cosine squared wt. And then we're going to add that to this thing squared, which is going to be r squared w to the 4th sine wt. So let's factor the let's factor out the r squared w4, so ds dt, second derivative, squared is going to be equal to r squared w4, w to the 4th, cosine squared wt plus sine squared wt, and we know this is going to be equal to 1. So ds dt, which is basically this is our acceleration, so let's take the square root of both sides. So we have ds squared dt, the second derivative, is going to be equal to r squared w to the 4th square root. And we know that ds dt, second derivative, is going to be equal to r times w squared. But this is our acceleration. But we know that velocity is wr. So we can factor out basically, we're going to have ds dt second derivative. If we put this in terms of our velocity, what we're going to get is, since velocity is rw, this would be velocity times w. But since we know that w is equal to our velocity, so basically our velocity over here is rw, and we know that w is going to be velocity times divided by r, we can plug this in here. So let's plug that in there. We get d squared, not squared, second derivative, dt, second derivative, is equal to v times v divided by r. And now we know that this acceleration is v squared divided by r. This is the acceleration in a circle. That's our answer. I hope this helps you. Please subscribe.